Hello, this video is for the IXL activity titled Solve Advanced Linear Inequalities. The three-character code for this activity is 9er Kilo 8. At the time of this recording, this activity can be found in Algebra 1, Section K, and it is Activity 10. All right, so they want us to go ahead and solve the inequalities, and we do have the variable t there in the first one, and we got a variable d over here. Remember, just like solving equations, the idea is that we want to isolate the variable on one side, preferably the left side, so we'll talk about that. This is advanced linear inequalities. If you've not done the one-step and the two-step inequalities, you might want to go visit that video. So, because I'll move through this kind of quickly and want to get to the more complicated questions toward the end. So, if you have not watched those, go ahead and go take a look at those videos. All right, so I always like to start with a rewrite. So I'm going to rewrite this. 2 is less than or equal to t plus 7 over 2. Now we want to get rid of the fraction, right? On the right there, we got that t plus 7 over 2. Best way to get rid of a fraction is to multiply times the denominator. The denominator is the number at the bottom. What we do to one side, we do to the other. On the left, 2 times 2 is going to be 4. We're going to bring down our less than equal to sign. The 2's are going to cancel each other, leaving us on the right with t plus 7. So now we need to get rid of the positive 7. We're going to do that with the negative 7. What we do to one side, we're going to do to the other. 4 minus 7, well, that should be what, negative 3. And let's bring down that less than equal to sign. The positive 7 and negative 7 are going to cancel, leaving us with t. Now, let's go ahead and move this up over here because we got one more thing we want to do, and that is we want to get the variable on the left-hand side instead of the right-hand side. So let's just go ahead and send our variable t over to the left, and let's send our numerical value of negative 3 to the right. And I hate to say it this way, but one way you can remember, make sure you get the arrow correctly, or the symbol, the inequality symbol correctly. It's pointing at the negative 3, so let's go ahead and make it point at the negative 3 still. So in the end, we end up with the solution of t is greater than or equal to negative 3. On the next one, we have 6 is greater than d minus 2, and all this is over 3. So we want to get rid of that fraction. Let's go ahead and multiply times the denominator. So we'll go ahead and multiply each side by 3, because what we do to one side, we have to do to the other. It's just like solving equations. There is one thing that has to do with negative numbers, and we're going to see that in a coming example. So 6 times 3 is, what is that, 18? And let's bring down our greater than sign. The 3's will cancel each other, and we end up with d minus 2. Now we want to get rid of the negative 2 with a positive 2. What we do to one side, we're going to do to the other. 18 plus 2 is going to be 20. And bring down our greater than sign. The 2's cancel each other, leaving us with d on the left. Now, if you're thinking that I'm going to group all these together, move them over to the side, and switch sides, indeed, that's what we're going to do. We want the variable on the left-hand side, so we're going to send the variable d over to the left, and we want our numerical value of 20 on the right, and it's pointing at the d, so let's go ahead and make it point at the d again. That is to say that 20 is greater than d is the same thing as d is less than 20. Now, in these next two questions that we have, they look very similar to the ones that we just had. They have fractions again, but one thing you probably noticed about them right away is that they do have a negative denominator, meaning that we're going to end up multiplying both sides by a negative number. So let's go ahead and take a look at that example. I have v plus 2, and all this is over negative 1, and this is supposed to be greater than 12. So we want to get rid of the fraction. We're going to multiply times the denominator. Well, it happens to be that the denominator is negative. And any time that we multiply both sides by a negative number or divide both sides by a negative number, we need to switch the sign. So let's go ahead and switch our sign before we ever do any more calculations. Let's switch that sign so that we don't forget. The positive or the negative ones are going to cancel each other, leave me with the numerator of v plus 2. And positive times negative is going to be negative, and 12 times 1 is 12. Now I'm in a one-step equation. I need to go ahead and subtract 2 from each side. The 2's will cancel each other, leave me with v, and this is actually negative plus negative, right? So two negatives are going to get even more negative, and 12 plus 2 is 14. So we end up with v is less than negative 14. On the next one, 1 is less than or equal to m minus 9. All this is over the value of negative 3. So I'm going to multiply by the denominator to get rid of the fraction, times negative 3. And what I do to one side, I do to the other. And yes, since this is an inequality and I'm multiplying both sides by negative, I need to go ahead and flip that sign. And I'm going to do it before I do any more math, before I cancel anything out, before I do any multiplying, flip the sign so that I don't forget. Negative times positive is negative. 3 times 1 is 3. The negative 3's on the right cancel each other, leave me with m minus 9. So just bring down whatever's in the numerator. Now I need to get rid of the negative 9 on the right here. So I'm going to add 9. What I do to one side, I'm going to do to the other. Negative 3 plus 9, well, what is that? Positive 6. Let's bring down my inequality symbol. The 9 is going to cancel each other. I end up with m. Now let's go ahead and send that m over to the left and send the 6 over to the right. And since I switched them, or it's pointing to the m, let's go ahead and make it point to the m still. And in the end, I end up with the solution of m is less than or equal to 6. Final answer for that question. All right, let's go ahead and look at our next two examples. We no longer have fractions. Instead, we're probably going to have to do some dividing because we got some multiplication going on. So let's first go ahead and just do a rewrite. Let's go ahead and rewrite this. 10 times the quantity of u minus 18. And then from that, we need to subtract 17. And all of this is supposed to be less than or equal to 3. Now, I do have this 10 that's being multiplied times the quantity of u minus 18. But before I deal with that, I need to deal with this negative 17 right here. So I'm going to get rid of the negative 17 with the positive 17. And you've guessed it, what I do to one side, I'm going to do to the other. So the negative 17 and positive 17 will cancel each other out. Now, all we need to do is bring down whatever we have left over. And that happens to be 10 times the quantity of u, not plus. Let's go back. There we go. Minus 18. And bring down our symbol. All right. We have less than equal to, and 3 plus 17 is 20. Now, there's a couple ways you could do this. There's what I think is a hard way, and then there's what I think is an easier way to do it. The hard way would be to start distributing the 10 into here and end up with 10u minus 180, and then we'd have to bring down our symbol, and then we'd have our 20, and then I guess we'd add 180 to each side. And I guess actually that wouldn't be too bad, right? Add 180 to each side plus 180, and these would cancel each other. We'd have 10u. And then this is going to be what, 200, and then we divide by 10 to get 20. Now, on the other hand, I prefer to do something a little bit different to try to get all that erased there. What I like to do is I don't want to deal with the big numbers like 180. Just so happens to be it works out rather friendly in this case. However, if I divide each side by 10, this works out really well because 20 is going to divide by 10 really easy. Now, if it created a decimal number, maybe not so much. But in this case, we're going to cancel those out. And you might go, well, what are you doing there? Well, if I had 10x and I divided by 10, it would just leave me with x, right? Because the 10s would cancel. Well, likewise, same thing here. U minus 18, it is a separate quantity that's being multiplied times 10. It's a factor between 10 and, well, it's a factor. It's being multiplied times each other. And just like 10 is being multiplied times x and you're just left with x, we're just left with the u minus 18. Bring down our symbol here, and then 20 divided by 10 is 2. Now let's go ahead and add 18 to each side, plus 18. The 18s would cancel each other, leave me with u on the left. Bring my less than or equal to sign, and then 2 plus 18 is 20. So either way, we would end up with u is less than or equal to 20. Totally up to you how you wish to do this one. I prefer, if the numbers work well, I would rather just go ahead and divide by whatever number is being multiplied times the quantity of what's ever in the parentheses and just get rid of it that way. Let's take a look at another example. So we have negative 11, and this is supposed to be greater than negative 1 times the quantity of g minus 17, and then we're supposed to subtract 12 from it. Now, before I deal with the negative 1 that's being multiplied times the quantity of g minus 17, I need to deal with this negative 12 right here. All right, so I'm going to get rid of that with positive 12. And what I do to one side, I'm going to go ahead and do to the other. So negative 11 plus 12 is going to give me a positive 1. Bring down my greater than sign. I haven't messed with any of this yet. Okay, so I still have negative 1 times g minus 17. Now the negative 12, positive 12 cancels each other, and I'm done with that line. I can now go ahead and work on the second line. Now I have negative 1 being multiplied times the quantity of g minus 17. So let's go ahead and divide by the negative 1. What we do to one side, we do to the other. And we just divided by a negative. So let's go ahead and flip that sign now before we do anything else. The negative divided by negative, or positive divided by a negative. Let me double check. 11, 12, positive 1. Yep. This is going to give me a negative 1. 1 over 1 equals 1. The negative ones here are going to cancel each other, and I'm left with what's in the parentheses there, which is the quantity of g minus 17. I can go ahead and get rid of the parentheses at this point. Now let's go ahead and add 17 to each side to get rid of these 17 over here. Negative 1 plus 17 is going to give me a positive 16. And bring down my sign, making sure, yep, I flipped it up there. And then I'm going to go ahead and bring my g because those cancel each other. And now I end up with 16 is greater than g. And at this point, one thing I need to do still is I want my variable on the left side. So I'm going to send my variable g over to the left, send my numerical value 16 over to the right, and I'm going to flip the sign. Again, since I changed the sides, I want to change the sign. Or it's pointing at the 16, it's still pointing at the 16. And my solution is g is greater than 16. All right, next question. In this activity, you're going to end up with variables on both sides. You can see over here on the left, we have 10p, and over on the right, we have 12p. But we're going to deal with this just like we did with equations back in the day when we were doing equations. Always good to do a rewrite, so let's start rewriting everything out. 15 plus 10p minus 19 is greater than 12p minus 20. All right. First, I need to combine some like terms. Notice that right here, the 15 and the 19, that both of these are constants, right? So let's go ahead and put those together. And this is a negative 19 right here. So I'm first going to grab my 10p, and I'm going to put my 10p over here. I like to get all my variable terms over to one side of the inequality. I like 10p to come before I want the p's to come before the constants, right? The terms with variables come first and the constants come later. So I've got positive 15 and negative 19. Well, together that's going to be what? Minus 4. 15 minus 19 is negative 4. Bring down my symbol, greater than 12p minus 20. Now let's get all of the p on one side, and then we'll deal with the constants after that. So notice I have 10p on one side, 12p on the other. They're both positive. So since they're both positive, I want to go ahead and add or subtract the one with the lesser absolute value. I want to take away 10p. And here's why. Because if I go ahead and subtract 10p from each side, if I take the one, since they're both positive, and if I take the one with the lesser value or the lesser absolute value, then I'm going to end up with a positive variable. Because check this out. The negative 10 and positive 10 are going to cancel each other. I still have the negative 4. Let's bring down my greater than sign. 12p minus 10p is 2p. So notice that my terms of p is still positive. Go back and check out the video on the lesson on solving equations with variables on both sides. I do a lot more discussion about that there. But since they're both positive, I want to subtract the one with the lesser absolute value. Let's bring down that negative 20. Now I want to get the constants on the other side. So let's go ahead and add 20 to get rid of the negative. So what I do to one side, I'm going to do to the other. Negative 4 plus 20 is going to be positive 16. Bring down my sign. Those 20s cancel each other. I end up with 2p. Now let's go ahead and move this over here, and I'll finish working on it over here on the right. Now I want to divide both sides by 2. What I do to one side, I do to the other. 16 divided by 2 is 8. Bring my sign down. The 2's cancel. I have p on the left or the right. Now I want to move my variable p over to the left. I want to move my numerical value 8 over to the right, and it's pointing at the p, so I want to go ahead and make it point at the p as well. So I end up with 8 is, or p is less than 8. All right, next question. We have 13 or negative 13, and we're going to subtract 3z. Great, they look like 2's. Is less than or equal to negative z, and we're going to add 5 to that. So I have variables on both sides, right? I have negative 3z on one side, positive or negative z on the left. Now, one thing I want to point out, and I'm going to change the color. I'm going to make it yellow. There is technically a negative 1 right there, okay? This is negative 1z. There is a coefficient in front of a negative variable. That coefficient is 1. It's just the invisible one. All right, bit of humor there that I like to share whenever it comes to that concept. So just if you have to, actually write a 1 in there so you realize that, hey, there's actually a 1 there. Some students will overlook that. So let's see. If I add 3z to each side to get rid of the negative 3z, then it's actually going to go ahead and make this one positive, right? So in this case, they're both the same sign, so I want to deal with the 1, and they're both negative, so I'm going to deal with the one that has the greater absolute value, which is negative 3. So in this case, I want to go ahead and add 3z, and what I do to one side, I'm going to do to the other. I'm going to bring down my, well, let's go ahead and do this yet, because these are going to cancel, right? So we're going to have negative 13 over on the left. Bring down my sign. Negative 1 plus 3 is going to give me a positive 2. So now you're like, oh, okay, I see why you did that, because you want a positive variable. If I would have added 1 to each side, then I would have ended up with the negative 2z on the other side, and I would have had a negative coefficient, and I like to work with positive coefficients. And I also have the plus 5 still needs to come down. Now let's go ahead and get rid of the positive 5 because I'm trying to isolate the variable z here. So let's get rid of that with a negative 5. And what we do to one side, we do to the other. Negative 13 plus a negative 5 is going to get even more negative and be negative 18. Bring down my sign. Bring down my 2z. And those will cancel each other. So now I end up with negative 18 is less than 2z. Need a little more room there. So let's go ahead and divide each side by 2. And negative divided by positive is going to be negative. 18 divided by 2 is 9. And bring down my sign here. I divided by a positive number, so I don't need to change the sign. And the 2's will cancel each other, leaving me with z on the left, or the right. Now let's move that z over to the left. Send my negative 9 over to the right. And it's pointing at the negative 9, so we'll make it point at the negative 9 again. Or we can say that negative 9 is less than or equal to z is the same thing as z is greater than or equal to negative 9. All right, let's look at another problem. Here we have 13 plus 12f is, or minus 12f is less than or equal to 14f minus 15. Well, one thing I noticed right away is I have a positive 12f and a negative 12f. Those are going to cancel each other out, leaving me with the 13 is all I have left over on the left. Remaining on the left. There we go. And go ahead and bring down my sign. And then I got 14f minus 15. So let's go ahead and add 15 to go ahead and get rid of the negative 15. And what we do to one side, we're going to do to the other. Looks like we're going to have, what, 28 over here on the right. That's going to work out really nice with this 14, isn't it? 14f and the negative and positive 15 will cancel each other. Now let's go ahead and divide both sides by 14 to undo the multiplication between 14 and the variable f. 28 divided by 14 is going to be 2. Bring down our sign. and 14's cancel, leaving me with f. And let's go ahead and grab that, move that over here. And now all we have left to do is send our variable f over to the left, send our value of 2 over to the right, and let's go ahead and switch our signs since they switch sides, and f is greater than or equal to 2 is the solution for this inequality. On the next question, here we are going to mix some things up. We've got 7a, we got variables on both sides. What else do we also have going on? We got a factor being multiplied times a quantity of 6a minus 19. So first thing we need to do is, well, this time we're going to have to distribute the 2 in. I can't really go, I guess I could try to divide by 2. What I do to one side, I do to the other, and then I'd end up with 7 halves a, and that wouldn't be all that fun to work with. So in this case, we do indeed want to go ahead and distribute this 2 in. So let's go ahead and bring down our 7a less than or equal to, positive times negative is negative, 2 times 6 is 12, and the a goes along for the ride, and then positive times negative is, yep, positive times negative. Yeah, they're both going to be negative. There we go. Yep. And 2 times 19 is, what is that, 38? There we go. Now let's get our variables all on one side. Well, I've already got 7a over on the left. I've got a negative 12a on the right. So in this case, let's go ahead and add 12a to each side. And 7 plus 12 is going to be, what is that, 19? 19 a's. The negative and the positive are going to cancel each other. And then now let's bring down the negative 38. Now let's go ahead and divide both sides by 19 to undo that multiplication between 19 and a. 19s will cancel each other, leaving me with a. And negative divided by positive is negative. And 38 divided by 19, well, that works out real nice. That's what, 2, right? So we end up with a is greater than or equal to negative 2. On the next question, we've got a couple things going on here. Looks like we got distributive property on both sides we're going to have to deal with. I guess we could divide both sides by 7, end up with 4 sevenths, but I don't think that's going to work out too well. So let's go ahead and do a rewrite. 4 times the quantity of negative 28a minus 42, and this is all supposed to be greater than 7 times the quantity of negative 19a minus 75. All right, so let's go ahead and bring in the calculator for this one and pull the calculator in. And on this one, we want to go ahead and do 4 times negative 28. I get 4 times negative 28. I'll need to, let's clear that. 4 times negative 28. That's going to be negative 112. And also, what would be handy to know is 7 times negative 19. And those will be a couple numbers that'll come in handy. So let's go ahead and deal with those. So the 4 times the negative 28 is a negative 112. And the a goes along for the ride. And we also had the 4 times negative 42, right? So we need 4 times negative 42. And on that, we get negative 168. So negative 168. Let's bring down our sign. 7 times negative 19 was negative 133. And the a goes along for the ride. And then 7 times negative 25. We got 7 times negative 75, and that's negative 525, so minus 525. Now let's go ahead and get our variables all on one side. Well, they're both negative, so if I add the one with the greater absolute value, that would take me to a positive, correct? So let's go ahead and add 133 to each side. 133a plus 133a. And over on the left, negative 112 negative 112, and we want to add to that plus 133. And that's going to give us 21. So we're going to have 21a. Let's bring down our negative 168. And the negative 133, positive 133 cancels each other. And I got minus 525 still that I have to bring down, right? Now let's go ahead and add 168 to each side. We do to one side, we're going to do to the other, 168. And I'm going to go ahead and do the negative 525. And I'm going to go ahead and add to that a positive 168. That's going to give me negative 327. So these will cancel each other. I'm going to bring down the 21a. And then negative 525 plus 168 was a negative 357. So we'll go ahead and we'll move all of this over here. And now, oh, I can't see that. It's over behind the, okay, let's put it over there. And now we need to go ahead and divide both sides by 21. We do on one side, we do to the other. So those 21s will cancel. So I end up with A is less than, and then negative 357. And we're going to go ahead and divide that answer by 21. And that will give us negative 17. Negative 17. So in the end, our solution to this lengthy problem is A is greater than negative 17. All right, let's go back to the other screen there. All right, our next problem. This is our final problem. It's decimals. So again, but we gotta have a calculator, right? So feel free to use a calculator for the decimals. However, these all have one decimal point. There's a trick I'm thinking. We'll go ahead and whenever I put this on here, I really wasn't thinking about it. So let's see if we can talk about a way that might make it a little bit easier. And I'm going to call the D's. Here's another trick I like to use. I like to just put all the variables as X's because X's don't look like other numbers. So 8.1x is less than or equal to negative 59.6x minus 3 times the quantity of negative 47.1x plus 75.76. And we just got another decimal place there. So I was thinking about multiplying everything by 10 to get rid of the decimals. We'll just go ahead and we'll deal with the decimals. All right. So over on the left, let's see. We're going to leave the 84.1x. Bring down our less than equal to. We're going to leave the negative 59.6x alone for now, and we're going to distribute. Remember, this is a negative 3 that we need to distribute in. So we're going to have negative times negative. That's going to give us a positive. And then over here, we're going to have a negative times a positive, and that's going to give us a negative. So let's do some work with our calculator. Let's go back to our calculator. And I'm going to go ahead and clear this out. Now I need a negative 3 times, oh, you can't see it over there highlighting. Okay, so negative 3 times negative 47.1. So negative 3 times negative 47.1 equals, and that gives me 141, 141.3, and the x goes along for the ride, correct? And then we have a negative 3. We're going to multiply that times positive 75.76. And that's going to give us a negative 227.28. All right, so now let's go ahead and we need to combine some like terms, and we need to get rid of that over there. So let's go ahead and do this. Let's do 84.1x less than equal to. Now let's combine the negative 59.6 along with the positive 141.3. So I need a negative 59.6. And we're going to add to that a positive 141.3. And that's going to give us 81.7. 81.7. And that's in terms of x. Don't forget the x. Let's bring down our negative 227.28. Now let's get all of our variables over to one side. So let's go ahead and subtract 81.7x from each side minus 81.7x. Over on the left, we have 84.1, 84.1, and we're going to subtract from that minus 81.7, and that's going to give us 2.4, 2.4 in terms of x. Bring our sign down. The positive and negative 81.7 is going to cancel each other. And now I need to bring down my negative 227.28. Now I'm just about there, getting closer, right? Let's go and move this over here. Now let's go ahead and divide both sides by 2.4. We do to one side, we're going to do to the other. And the 2.4s will cancel each other, leaving me with x. Bring down our less than equal to sign. And then we have negative 227.28. And we want to divide that by 2.4 equals. And we end up with negative 94.7. Wow. Now we could go plug that back in, but I really don't feel like doing that. All right. So those are all of my examples for the IXL activity solve advanced linear inequalities, 3-character code, 9 kilo 8. Good luck with your activity.